in many situations, what really happens is that there are errors that are acceptable, errors that are not acceptable, right? So you put a margin of error that you would like. Now, for the example, the World Vision International example, we found that the mean was 233,000 in costs for a program, and the error would basically go from 215,000 to 250. So it was something along the lines of $17,000. Now this may be an error that is acceptable, but perhaps it's too high, okay? Perhaps it's too much. And so one possibility would be to say, no, I'd like my error to be really small. So we were finding $17,000. That gave us an interval that went from 215,000 to 250,000. What would be acceptable?
About
20,000. Oh, so up and down. So perhaps 10,000 error.
Yes.
Okay, so let's work with that. So let's work with an error that is 10,000. And so what we would say is, we have a $10,000 here error, and now we would like to know what would be the sample size that would give me that. Now, we can maintain the 95% confidence, and perhaps we'll do so not to introduce another variable in the program, but we're free to choose, okay? And what we do is basically now isolate n with respect to the other variables, okay? So that's what the formula there shows. Now what I'll do here is I will keep the error of 10,000, sorry, in a place mark here, and we'll do the calculation, numerical calculation in a bit. But what I'd like to do is basically compute what n should look like. So the first thing that I'm going to do is I'm going to square everything. And so now I have the error square is equal to the z value squared, the standard deviation of the population squared, divided by n.
Why you are squaring?
Because I want to isolate n, right? I'd like to find out what is the normal, the sample size that will give me a desired error. Before we did arbitrarily, we selected a sample size. And we said 50, 100, and so on, and we got results. Now, I'm coming from this managerially perspective that I'm saying, no. So just getting results is not good enough. I'd like my forecast or my estimation, to have a specific error, to have a specific margin. If it's too high, well then, for managerial purposes, it's not useful. Okay? So, before we were computing the error, now I'd like to compute the adequate sample size. And so I squared it so I would get rid of the square root. And now I just isolate n. So I can multiply both sides by n. So I'm going to multiply both sides by n. And it cancels on that side. It stays on that side. And I'm going to divide everything by e squared, the error squared. So what we get is the equation that you see there on the board. Okay?
Let's say that the sample was 100.
Yeah. And the error in the case of World Vision was 17,000, give or take. But Dixon said, well, this is too high.
So we square 17,000?
Nope. We're not even thinking numerically.
Okay.
We're not worried about the numbers. The concept is, before we came from a point of view that we knew that our point estimate was wrong, and we knew that we needed to include an error. And therefore, we said, using the definition of the z-score, right? Using the definition of the z-score, we can write something like this, where our point estimate subtracted by the true mean gives me dimensionally a notion of what an error is. Okay, so perhaps I can actually add to my point estimate an error defined this way. And we only arbitrarily selected a sample size of 100 and saw what was the consequence of that with a specific confidence level. Okay?
Can I just reword that?
So the following, what we're doing now, so just a minute, Becky. So what we're doing now is the opposite. So this was just to set up and actually say, we have a point estimate plus or minus an error. Now, we're coming from a point of view of, well, we actually would like to know the appropriate sample size that would give me an error of a specific length that is acceptable managerially so that I can go make decisions.